counting subatomic particles. Okay? All right, so I'm going to write it on here. Counting subatomic particles. Now, counting subatomic particles really and truly is not that bad, but the problem is sometimes you look at the chart or the information given to you all at once, you get all nervous, right? But the key is understanding the structure of the atom. Now before, right guys, remember we studied the different models and we got to the Bohr model, okay? Now we're gonna use this this setup right here, this visual right here to represent our atom. Now this center right here, this part right here in the middle represents a nucleus. Now we know from experience, right? This is not to scale, okay? But for emphasis. So let's look at lithium, for example. Now guys, you need your periodic table, guys, okay? Now if you say lithium, right, one thing you gotta know is that the protons of the atom, let me write it down right here, the protons, P+, right? They give the atom its identity, okay? Please make a note of that. Now the number of protons also is called the atomic number, all right? So the atomic number is the same thing as the number of protons, critical, okay? So anytime you're filling out a chart when it comes to subatomic particles, the atomic number of protons always should be the same, okay? No problem, bam. So that's one thing you know. Now let's look for lithium, Li, okay? It's gonna have 3 protons. Now where do I put them? That's the question. Do I put them in the energy levels? We know from experience, right, that the protons belong inside of the nucleus. I'm gonna put 3 positives in there to represent the protons in the nucleus, okay? Alrighty. Now it just so happens that there's another particle inside the nucleus called the neutrons, right? So we have protons and neutrons inside the nucleus. So there just so happens to be, okay, 4 neutrons, okay, neutral guys, inside of the nucleus along with the protons. So another note that you should make, folks, it's very important, is that the protons and the neutrons, okay, are in the nucleus, right? And they have a funny name, a special name, okay? They're called nucleons, okay? Sometimes that gets students a bit, upset or whatever. Don't worry about it, okay? Nucleons belong to the nucleus. And what are they? The protons and the neutrons, all right, okay. Now, our electrons, guys, are in the energy levels. Now, we discussed it briefly, right? The electrons cannot go randomly anywhere in the energy levels, right? Each energy level has its own specific capacity for electrons based on the 2n² rule, which we'll talk about soon or later, okay? So the first energy level is energy level number 1 right here, okay? He can hold 2 electrons maximum, okay? So we're gonna put 2 electrons right here. Put 1 there, alrighty? I'll put 1 on this side, all right, bam. And this energy level right here, this outer energy level, the second one, okay, can hold a maximum of 8 electrons. Well, we only have 1 more. Remember, lithium only has 3 electrons. Now, one more thing you should write down, guys, is that if the atom, right, the overall atom is neutral, okay, the number of protons will be equal to the number of electrons. That's very, very important for us, okay? So let's recap real quick. Atomic number is the number of protons. They go hand in hand. They're always gonna be the same thing. The protons and neutrons are located in the nucleus. They give the atom its mass, okay? They're also called nucleons, all right? And one more thing. The atom is, if the overall atom is neutral, that means the number of protons, 1, 2, 3, is equal to what? Is equal to the number of electrons, 1, 2, 3. So this is a nice neutral atom of lithium, okay? Now there's one more thing I want to tackle, guys. It's called nuclear charge. Alrighty? What's nuclear charge? Charge in nucleus. Now what particle has charge in nucleus? So you look here, you have the neutrons, and you have the protons, right? The protons carry the charge, all right? So if they ask you what's the nuclear charge, okay, simply look to see what's inside the nucleus. Simply look to see how many protons does the atom have. And whatever number of protons, the number of protons that the atom has, that's gonna be the nuclear charge. And it's always gonna be positive, people. It'll be positive some number. okay? And the positive the number is, the number of protons. So the nuclear charge for lithium, right, will be +3 or +3, all right? Bam, okay? So anytime they ask you nuclear charge, don't think about the whole atom, just think about how many protons are in nucleus, and it's positive that number of protons. Okay, so we'll continue in a second.